Wonderful to see so many people here today. We're really grateful that you came. Thank you for putting up with the logistic hurdles that we had getting everyone here in the room. My name's Scott Shang. I'm with Landesa, and on behalf of the Columbia Center for Sustainable Investment, the Columbia Law Center and the Sabin Center, Columbia Law School and the Sabin Center, Landesa, and Wake Forest Law, we want to welcome you here and thank you again for coming. I really want to thank Selena and Sam for having done an amazing job with the logistics for this event. It was no small feat in the middle of UNGA and Climate Week and a demonstration outside and 600 people registering for this small space. So thank you so much to their efforts. And thank you to the speakers who've come. A lot of people are extremely busy. Mike Gerrard was telling me this is his 7th of 8 talks this week, so hopefully he won't fall over after he's done with this. In terms of logistics, please know there are microphones on the table. We want to make this as interactive as possible. We also want to make sure we capture what you're saying. We're both live streaming this and recording it, and if you don't use the microphones, we'll miss your contributions, so please do use those. They're already on, and the wonderful team from Ford Foundation will activate your mic when they see you with it and ready to speak. I think as you saw, there's some snacks out there, and the restrooms are on the other side of the snack bar. So if you have any questions or need anything, let us know, and thank you again for coming. We're going to start up with Mike Gerrard. Mike Gerrard, of course, is professor of environmental law at the Columbia Law School. He's the director of the Sabin Center for Climate Change Law, and he's former chair of the faculty of the Columbia Earth Institute. So we're really grateful for Mike both helping us put this together and for kicking us off.
Thank you, Scott. It's a great honor to be here at this very important meeting, and I'm going to give an overview of the messages that we are going to be talking about throughout the day. The basic idea is that there is a tremendous increase in demand for land. The demand for land is going up without respect to climate change. Climate change is increasing the demand for land. Their measures to cope with climate change are increasing the demand for land, and the supply of land is decreasing because of climate change. All of this has very significant implications for people or peoples who do not have clear title to the land, that they're going to be squeezed. The absence of land tenure in combination with this increased demand for and decreased supply of land is going to be a very serious situation for people without clear land tenure. The IPCC in August, just last month, released a very important report, Climate Change and Land. It highlighted these issues. It made it clear that even at 1.5 degrees centigrade increase in global average temperatures, there will be very serious environmental impacts. At 2 degrees, which is 3.6 degrees Fahrenheit, there would be much more serious environmental impacts. The Paris Climate Agreement is based on non-binding voluntary pledges, and if all those pledges are carried out, that takes us to over 3 degrees, and most countries of the world are not even carrying out their pledges. So we may well, by the end of the century, be at a world that is 4 degrees or something in that range. Just 2 days ago, the IPCC released a new report on oceans and the cryosphere, which is even further ringing alarm bells for what the future may bring. So the first item here is that the demand for land is going up without respect to climate change, and of course population growth is at the heart of that. There are now about 7.7 billion people in the world. It's projected to go up to maybe 11 billion by 2100. Global rates of population growth are declining, but we still have growth that is happening, and so that's about 3 billion more mouths to feed. Already, about 40% of the Earth's land surface has been converted to agricultural production. More will have to be converted unless we find some way to produce food more efficiently, consume food more efficiently, and but this is a lot of mouths to feed. There's one sort of conceptual formula that is often used to think about the interrelationship of these issues. IPAT, impact equals population times affluence times technology. So the population is going up, so is affluence, and an increase in affluence which is a good thing as a general matter, is also increasing consumption. And one area where it particularly has an impact on consumption that bears on land use is in food production, and especially meat production. So increased land affluence means that there's more demand for resources of all kinds. There's more demand for food, for fiber, for timber, for energy, for metals and other minerals, but especially noticeable, especially important is the increased demand for beef, which is one of the most land-intensive ways of producing food. And as some countries have increased their affluence, they have also increased their per capita consumption of meat. This chart shows meat consumption per capita, and you can see that China is, let me see if this works. I think that I don't have a pointer here, but you see that the per capita consumption of meat by China has increased dramatically over the last several decades as their affluence has increased, and the same for Brazil. So that's per capita. In terms of absolute amount of meat consumption, so just comparing the U.S. and China, going back to 1960, we see just a dramatic increase. This parallels very much the charts we see about the increase in energy use and greenhouse gas emissions from China, but that's also happening with their meat consumption. As that meat consumption goes up, more and more land is diverted to grow soybeans and other animal feed. A lot of forests are being converted into soybean farms and that kind of production. The quest for food security has also led many countries to acquire large areas of land in other countries so that they can be sure that they can feed their populations. China hosts about 20% of the world's population, but only has about 7% of the world's arable land, and so it has bought a lot of land in other countries. Some of the Gulf states are also outsourcing food supplies through investments in farmlands outside their borders. So that's how the demand for land is increasing even without climate change. But climate change itself is increasing the demand for land in different ways. The first is, of course, sea level rise. We know that the seas are rising, that there's a wide variation in forecasts of future sea level rise, depending mostly on global greenhouse gas emissions in the coming decades, but also there's a lot of uncertainty about the dynamics of the West Antarctic ice sheet and the Greenland ice sheet, and some of the more recent information about that is not encouraging. But 2-meter sea level rise by the end of the century is one plausible outcome. Could be less, could be more. But if it's 2 meters, this is an estimate of the number of people who now live at levels that are below 2 meters above sea level and will be displaced in some fashion unless seawalls or something like that are built at just enormous expense. And of course, if you're in a house that is 2.2 meters above sea level, it doesn't mean you're safe. We also have storm surge and other events that raise the water higher. And even if your house is above where the water is, the roads you rely on may not be. Other infrastructure may be submerged. So we have a very large number of people who are going to have to move someplace. Where will they go? Are we going to see the creation of a lot of new cities? Are we going to cram everybody into existing cities? Will the perimeters of existing cities move outward? Will people be dispersed at low densities? The only scenario which doesn't require enormous amounts of land for the population is if everybody is crammed into the existing cities. But what will probably happen is some combination of all of the above. And of course, at the same time that existing cities are underwater, so are a lot of agricultural lands. And places are going to have to be found to grow, to replace that lost agricultural land. One of the things we hear a great deal about these days is the idea of managed retreat, advanced planning for the inevitability that people are going to have to move away from certain areas. Columbia hosted a major 3-day conference on the subject in June. But there's a whole lot more discussion of where people will retreat from than where people will retreat to. And we've not come up with anything approaching a coherent plan for where all of these people, the numbers here add up to almost 200 million people. Again, a whole lot of uncertainty, plus or minus, but that gives you a sense of the order of magnitude. No clear plan for where they are going to go. One of the things they will need wherever they go is a supply of water, and not every place where there is land is there adequate water, and often if the water, if it's from rain-fed watersheds or rain-enhanced aquifers and so forth, that needs a lot of land set aside to make sure that the land maintains its purity. So these are some of the ways in which climate change is increasing the demand for land, increasing the need for places to accommodate uses that have to move from places that are no longer habitable. There are also measures to cope with climate change that are consuming a lot of land or will consume a lot of land if they're adopted. The IPCC has shown that the existing Paris pledges, as I said, are not nearly enough. There's going to be an overshoot of the emissions that would be acceptable if we were to keep the temperature rise to within 1.5 and 2 degrees. And the only way to keep the temperatures down within that range is through carbon removal, net negative emissions. By the second half of the century, we are going to need to be removing massive amounts of carbon dioxide from the atmosphere. We're going to need to be removing more from the atmosphere than we're putting there. So net negative emissions. As it now stands, land is simultaneously a source of CO2 and a sink for CO2. Some of that is because of natural drivers, and some of that is because of anthropogenic drivers. According to the IPCC land use report from last month, on a net basis, global land use and land use change add up to land being a net emitter of about 5.2 gigatons of carbon dioxide a year. This is mostly due to deforestation. It's partly offset by afforestation and reforestation, and emissions from other land use activities, most importantly agriculture, are adding to the net emissions that are caused by land use. But this needs to completely turn around. We need to turn global land from being a net emitter of greenhouse gases to a net sink of greenhouse gases if we're going to come anywhere close to meeting the Paris objectives. The IPCC reports have also said that all of the modeled pathways that they've looked at to stay within that temperature range require land-based mitigation and land use change with some combination of reforestation, afforestation, reduced deforestation, and bioenergy. So first, afforestation and reforestation. There was a study that came out a few months ago that said that we could actually solve the problem of climate change and get down to acceptable levels of greenhouse gas emissions if we were to merely plant 1.2 trillion trees across 2.2 billion acres of land worldwide. That's impressive, but that is a completely unachievable amount of land use. 2.2 billion acres is about the size of the United States. And how to find that kind of land for afforestation is, let's say, challenging. So we do have a lot of forests around the world that are currently performing the important ecological services, including absorbing of CO2. We know from events in the last few weeks that the current government in Brazil is not a big fan of preserving the Amazon, and there are a lot of concerns about what's happening in that very important forested area. Another action that is being taken to cope with climate change that has enormous land impacts, of course, is biofuels. And the panel after this one will talk about biofuels in more detail. But this is just maps out the growth in biofuel use just to 2010, and I think others later may talk about projections going forward. But biofuels can be an important way not to use fossil fuels, to reduce greenhouse gas emissions that way, but they are an enormous consumer of land. And so a lot of forests are being converted into biofuel plantations of various kinds. Additionally, in order to reduce the use of natural gas, an important fossil fuel that doesn't emit as much at the point of combustion as coal, but it still emits a lot of fossil fuels. In order to replace a lot of that natural gas, there is talk about biogas, about converting biological products into gas that is pipeline quality that can serve the purposes that we now use natural gas for. That would be another tremendous increase in demand for land if we were to use it. Another area another sector that may want to use, will want to use a lot of biofuels is the aviation industry. Until we get to the point where we have such intense battery shortage that airplanes, large airplanes can run on electricity, biofuels seem to be one of the prime alternatives to continued use of petroleum-based fuels, or one way to reduce the use of petroleum-based fuels. That can lead to an enormous increase in the demand for biofuels. Speaking of the aircraft industry, the International Civil Aviation Organization, the UN body for aviation, has decided that the principal method that they're going to use to try to deal with the enormous and growing aircraft emissions is through an offset program that will primarily be based on afforestation. It looks like it'll be similar to the REDD+ program. And as many of you know, the REDD+ program has been plagued with issues about the treatment of the indigenous populations of the forests that are being preserved in some fashion through this. But when the ICAO program gets going, called CORSIA, that's going to lead to a lot of additional pressure for forest preservation in a way that could imperil those without good land tenure. And so that's something that will be very important to keep an eye on as the procedures and regulations for the ICAO aviation offset program are developed. Perhaps largest of all in terms of potential impact of efforts to fight climate change have on land use is bioenergy capture and sequestration. And so the IPCC has looked heavily to that, bioenergy with carbon capture and storage. And the BECS, and the basic idea is that you grow lots of fast-growing trees or other vegetation. You burn it in a way that you capture the emissions. They don't escape into the atmosphere. It creates energy, it creates electricity that is utilized, but the captured CO2 has to be sequestered in some fashion. So this involves growing a whole lot of vegetation, but not for food, for burning, with the idea that you're releasing the carbon dioxide in doing that, but you're capturing it, so it's not getting into the atmosphere. The IPCC report of August said that modeled pathways limiting global warming to 1.5 degrees centigrade, relying entirely on BECCS, would require up to 7 million square kilometers of land. That's slightly more than the land area of Russia, or slightly more than the combined land areas of the United States and Canada. So clearly that's not going to happen. But if we have bioenergy just for 2 degrees rather than 1.5 degrees, there's a broad range of land use requirements that come out of these models. At the low end is 400,000 square kilometers, which is about the size of Bolivia, up to 6 million square kilometers, which is a little smaller than Russia. Russia is 6.6 million square kilometers. And doing this at whatever scale involves a very large consumption of water, possibly of fertilizer, possibly of pesticides, whatever other inputs need to go into growing this massive amount of vegetation. Other forms of renewable energy can also consume a lot of land. So solar panels, if installed at a large scale, can consume a fair amount of land, although nowhere near what BECCS would consume. And there are techniques of mounting the solar panels that are being developed that allow plants to be grown underneath. Wind turbines don't have a large footprint. The cows can happily graze around the pillars, so that's not a huge land issue. There is a lot of discussion of using desert area for solar panels. There's a proposal that has been made to put a very large solar installation on the desert in Jordan and send a lot of that electricity to Israel to operate desal plants that would take water from the Mediterranean and desalinate it and send a lot of that water back to Jordan. So it would be a solar energy for water swap, which actually makes a lot of sense. And it might be doable if we had more friendly relations among all the peoples of that area of the world. If major new dams are built, that obviously also would be a major water consumer, but I think that there are going to be limitations on the number of new dams that are built. And then finally, in terms of actions to cope with climate change that consume a lot of land, E.O. Wilson, who is a famous biologist at Harvard, issued a book a few years ago called Half Earth, suggesting that half of the Earth's land surface be set aside as biodiversity preserves, which would be a rational thing if the highest priority were preserving biodiversity, which is an extremely important thing to do, but again, the idea of using half the Earth's surface for that is not something that is in the cards. So these are the ways that coping with climate change is increasing the demand for land. And then finally, we have those things that are those ways that climate change is reducing the supply of land. Sea level rise is the most prominent of those, and I already talked about that. The significant coastal areas and some small island states entirely will be underwater as a result of climate change. People live along the coasts because those are the best places to live. They have good access to oceans and water transport and livable climates in those areas. Trillions of dollars of investment in buildings and infrastructure and so forth are in these locations, and a lot of that is going to be underwater. But it's not only coastal flooding that is an issue. There's also inland flooding. As it gets warmer, if you're in an area that has water, it leads to a great increase in precipitation. Just a few months ago, we had massive flooding in the Midwest of the United States. Other parts of the world have also had record-breaking inland flooding. That flooding not only destroys houses, but it also swamps a lot of agricultural lands. It's wiped out a lot of fields. It's killed a lot of livestock, has various impacts. Now, will this cause people to move from those areas? If these were really 500-year storms, then probably not. But when you begin to have 500-year storms every 3 years or so, then it begins to have a real impact on where people are willing to stay. And so we're already seeing in some specific areas people deciding that a given town is just too vulnerable. We're going to have to move out of the town. We may see more of that. So, of course, it's often said that one major impact of climate change is it makes the wet places wetter and the dry places drier, which it does, and it makes the dry places a lot drier. And so the various projections about where future drought conditions can happen. And these droughts, of course, cause a great decrease in agricultural productivity, in livestock productivity. They can render large areas unsuitable for grazing, which is an activity on which about 800 million people depend for their livelihoods. Human populations will experience water insecurity. We've already seen how the adverse effects of that in the Sahel region of Africa and in parts of the Middle East, where persistent droughts have been claimed to be one of the contributors to the civil wars in Darfur and Syria. They didn't cause them, but they made them worse. They contributed to them. We've seen some cities face real water crises. It appeared that Cape Town, South Africa, was about to run out of water. They managed to fix that. There may be a looming water crisis in Gaza, where about 2 million people live. There are a lot of concerns about what will happen with the water supplies in South Asia as the Himalayan glaciers melt and we have the loss of that kind of water supply. So we have drought, and at the extreme end of it, we have desertification, areas that just aren't really suitable for much of anything, maybe solar panels, but beyond that, there are very limited things you can do with them. Then we have heat. So this is from the National Weather Service. There are combinations of temperature and humidity that are beyond the levels of human endurance. And so what this chart shows is the combinations that lead to various degrees of caution, danger, or extreme danger. And when you get to the lower right-hand portion of this, they don't even bother to say anything. So there are combinations that are not endurable by humans outside of air conditioning for more than a few hours. That particular combination has apparently not yet been happened on Earth in recorded history, but some places are getting awfully close. And when you get close, you have increases in fatalities. And there are areas, particularly in India, Pakistan, Bangladesh, and the North China Plain, where a total of about 1.5 billion people live, where by the end of the century, we may have protracted heat waves that are pushing up against these limits. Parts of the Persian Gulf also have this kind of vulnerability. So this is not a year-round condition, but it can last long enough that people are going to have to leave, maybe for protracted periods of time. The heat and drought also lead to more wildfires. We saw, in California, the city of Paradise was incinerated in a matter of a couple of hours, unexpectedly. Lots of other wildfires, not only in California, but in the Arctic and various other places. And that, too, leads to questions about what is acceptable risk? Where are people going to be willing to live, depending on what the risk is? Now, after all of that, after all of these uses of land, the unused land is what we used to quaintly call nature. It'd be the parts of the world where humans are not using them, and you could call it biodiversity, whatever it is, but it's nature, and that's going to be squeezed out as there are more and more uses, more and more demand for a declining supply of land. So the final thing I wanted to say is the IPCC land report had a paragraph that I'd like to read because it's directly on point with what we are talking about today. Insecure land tenure affects the ability of people, communities, and organizations to make changes to land that can advance adaptation and mitigation. Limited recognition of customary access to land and ownership of land can result in increased vulnerability and decreased adaptive capacity. Land policies, including recognition of customary tenure, community mapping, redistribution, decentralization, co-management, regulation of rental markets, can provide both security and flexibility in response to climate change. So there's a lot of talk these days in the context of climate change about the just transition, and much of that focuses on making sure that coal miners have jobs and that kind of thing. But another important area of just transition will be, what about all the large numbers of people around the world who don't have clear land tenure? What's going to happen to them as there are increasing demands on a reduced supply of land? Thank you all.